Okay, Bismillah Rahman Rahim. Our today's topic is polynomial based modeling. Okay, so we will have a quick look of the basics of polynomials. Uh, we can define a polynomial as a polynomial is an expression consisting of variables and coefficients that involve only the operation of addition, subtraction, multiplication, and non-negative integer exponents of variable. For example, 5x or x squared, these are different polynomials, okay? And these values should be whole numbers, okay? The coefficients, okay, as well as the power, these should be whole numbers. In polynomial there is no fraction and negative power such as x over y. So x over y, in this case the power of y is -1, so this is not a polynomial. Similarly, x raised to the power -2 is also not a polynomial, okay. So now the basic definitions. First is the term. So term is a number or a product of number and variable raised to a power. Okay. For example, 3 is a term, 5x square is a term, -2x is a term, 9x square y. These are different terms. This is one term, this is another term, this is another term, this is another term of a polynomial. Okay, now coefficient. So coefficient is the numerical factor of each term. Okay, for example, 5 is the coefficient, -2 is the coefficient, and 9 is the coefficients. Okay, so this is the numerical factor of each term. And constant, so the term without a variable. For example, this 3 is a constant. For example, 3 minus x, 5, 32, these are constants, and these constants don't have variable values. Okay. Now, what is polynomial? Polynomial is a finite sum of terms of the form AXN. Okay. So this is an important definition. A finite sum of terms of the form AXN, where A is a real number and N is a whole number. A is a real number and N is a whole number. And it is a finite sum of terms. So this is one term, this is another 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 term, and so on. So polynomial is sum of terms. Okay. For example, -15x cubed plus 2x square minus 5. So this is polynomial. This is a sum of three terms. This is one term, this is second term, this is third term. So it's a summation of three terms. Okay, same is the case here. It is a summation of four terms. Okay, now monomial. So a polynomial with exactly one term is called monomial. Okay, these are different monomials. Binomial, a polynomial with exactly two terms is called binomial. Okay, and trinomial, a trinomial, a polynomial with exactly three terms. Okay, and if we talk about poly, so poly mean many, mean many terms. Okay, now the degree of a term with one variable, the exponent on the variable. So 5x square. Now the exponent on the variable, this is 2 is the exponent of the variable. So the degree of this term is 2. Okay, because this is the power of the variable. Here the degree is 4 because 2x raised to the power 4. So the highest, the power is 4. Okay. Minus 9m, here the degree is 1. Okay, now the degree of a term with more than one variable. If there are more than one variable, so what will be the degree of that variable? The sum of the exponents on the variable. Okay, now for example, -7x square y. So the sum of the exponent on the variable 2, the power of x is 2 and the power of y is equal to 1. So the degree is 3. Okay, 2x raised to power 4 and dot y raised to power 2. So here the degree is 6. 4 plus 2 is 6. Okay. Okay, the greatest degree of the term of the polynomial variable. Okay, x raised to the power 3 minus 3x plus 7, uh, and it is here. Okay, now the degree of a polynomial is the greatest degree of the terms of the polynomial variable. So here we have three different terms. 2x raised to the power cube is one term, 3x is another term, 7 is another term. Now the greatest degree of the term of the polynomial variable. Okay. Now, polynomial and polynomial function and how it is practically used. So evaluate each polynomial function. Okay, sorry. Now, let's say this is a function fx is equal to 3x square minus 10. And if you want to evaluate this function for minus 1, so we will put 1 at place of x. Okay, so 3 and 2 minus 1 square minus 10 is equal to uh, minus 7. Okay, now let's say we have this another function gy is equal to 6y square plus 11y minus 20. Now if you want to evaluate this y for 3, so here at place of y we will put 3, here we will put 3, and we will get the final values. Okay, so this is how a polynomial is evaluated. Okay, polynomial and polynomial function and multiplication. So I think at school we have already learned how polynomials, the multiplication process in polynomial is performed. This is very basic steps. I hope you already know this. Okay, this is basic things. Uh, so I don't want to waste time on this because you already know how multiplication is performed in polynomial spatial product, multiplying two binomial using FOIL. FOIL means first term, outer terms, inner term, and last term. So now, for example, so x plus 3 and 2x plus 4 is equal to x by x plus 4x plus 3x plus 12. So you already, I hope you already know this. This is the same multiplication process, but at this stage we are not interested in these basic mathematical operations because you have already learned these things in school. Okay, division, it is all clear, I hope. Now we are interested in the applications of these polynomials. Okay, I think I had already in one of my previous lecture, I had explained how polynomials are used for modeling. Okay, now for example, here this is independent variable x and this is dependent variable y. These are the values of x and these are the values of y. We have these different points, and these points can be modeled using polynomials, and if we compute the model, so we will get this function. Okay, so this is the applications of these polynomials. This is another example. And okay, if you have forgotten, so I will try to have another example so that you remember what we had already done. Let I try if these variable will work. Okay, let's say I have okay, good. Okay, so let's say I have these variables, and I plot these variables. Let's say insert. Okay, this is 1 minute. Okay, okay. Let's say I have these values, and instead of dots, I should take scatter. Okay, I have these points, and now I am interested to develop a model for these points. So in one of my previous lecture, I have already explained this in context of, I think, mean square error, or in some other examples. But here in Excel, we can create a model based on polynomial. Okay, you can select this add trend line. Okay, and now just look. Okay, sorry, 1 minute. Okay, sorry. Okay, add trend line. Okay, and here these are different functions. Okay, so if we take a linear function, so this is the function, and we should also display the equation. So this is the equation. And if, but we are interested in polynomial, so if we take an equation of order 2 polynomial, so it will be this. If you take of order 3, so this is most closely related. And if you already remember the value of r means the error. So if we take a linear equation, so the error is 0.0095. If you already remember, if the value is close to 0, then this means that the error is too high. And if it is close to 1, then this means that the model error is less. Okay, so in case of linear equation, if we have this equation, so the the 1 minute is here. Okay, now this is the linear equation for these points, and this is the r square is the error is too high. Okay, so we wouldn't select this one. Okay, sorry, I just do it again. Okay, okay, now these are our points at trend line, and I show the equation and the r value. And now if I take a logarithmic equation, so the r is improved, but not that much. Now if I go to polynomial, so polynomial of order 2 gives us an error of zero point 0.1. Okay, and if take a polynomial of order 3, so the error is now zero point 0.1. And if I go to order 3, now the error is reduced, and now it is 0.8. As you already know, that a value close to 1 means that the model is more accurate as compared to the model where the value is far away from 1 or close to 0. Okay, so this is the use of polynomial. That is, we can model, we can create model for a situation where the the system is non-linear, and where we can't use linear functions. So in case of non-linear functions, we can use polynomial for modeling these points. Okay, now this was one example of these polynomials, and now the other very important use of polynomials are splines. Okay, so what are splines? Splines are piecewise polynomials. In computer graphics, a spline is a curve that connects two or more specific points, or that is defined by two or more points. We can also call the polynomial as spline as piecewise polynomials. Okay, spline is a mathematical function used for interpolation or smoothing. Lower degree curves are used. Spline allow matching condition. So in summary, sometimes there are many points and we can create models using polynomials, but in some cases it gives some complicated polynomials of higher order. In some cases, the order can go to 5, 6, or 7. And in that case, we get a complicated model. So instead of that, we divide the points into some groups and we create small functions for each set of points. And then we connect those points and get a final equation. So that is called spline. Okay, spline linear, quadratic, or cubic. Okay, so I will talk about these in my next lecture. Okay, thank you.